Hey everyone, so for the sort of latter half of what we're looking at, I actually am gonna, well, I'll just start with this is my Excel file, right? So as we discussed in class, you might have some issues. You can see that I've actually saved this as an XLSX. And so I am going to, I have one version of it saved. I'm gonna actually take out my calculations, column, and sort of clear this bit out, and then save a clean copy that I can use in. Oh, I hate that Macs don't have a proper delete key. It's like one of my pet peeves. Okay, and so now I'm going to save this under a different file name. So I'm going to call this Apple Refine. That I am going to use to open in OpenRefine or Google Refine. You guys have OpenRefine, I have Google Refine. So your version might look slightly different on your computer or on the lab computers, but it's in principle the same thing. So again, I'm going to open this up. One thing you might run into is that the older versions, the version that I have, automatically opens this this IP address, which is a local IP address. If you launch OpenRefine and nothing happens, then what you need to do is actually open up a web browser like Chrome. I happen to be using Firefox, but that's fine. And actually paste in this web address, this 127.0 IP address, 127.0.0.1:3333, and then that is the location. You can actually bookmark that, and that will be your OpenRefine address, and you can just click a bookmark in order to get there in the future. But to see this work, I'm going to open my XLSX. It's a tough one. And again, you'll see that this is a very similar process to what we saw in fusion tables. It's or really anytime you're importing data into a spreadsheet-like program, right? And so again, I would probably want to change this name. You guys will want to keep track of this stuff. And I'll do again just very quickly the demo of sort of the things that you can do with the faceting here. So for example, if I click on this, one of my options is to do a text facet. That text facet will tell me sorted first alphabetically, or if I prefer by count. It's going to show me all of the different options and how many times they appear. It gives me the number of choices, the total number of rows. I can go through and put on additional facets. And when I initially do these facets, right, we see that it doesn't actually change the data set. I'm still seeing the entire data set, but I can subselect and do just which ones of these there are, and there are 45 matching rows there. And you also see that these counts are affected by one another. So if I say, okay, exclude this, as soon as I clicked extra fancy, you can see, so look, if you keep your eye on red delicious and you see how I do extra fancy, it's automatically running that filter, right? And it's automatically updating the count. So we can tell that there are 4 types of apples because we had 16 originally, and when we use extra fancy, there are 4 types of apples that don't have extra fancy as an option, right? So all of this can facilitate sort of, ways of just kind of quickly checking through and looking at our data, and finding out a bit about what's happening. But we also have this numeric facet option. And that's what we're going to apply to our high price, and that's what we're going to combine with our knowledge, our data here about. Oops, I need to open the other one. The data that we generated about the mean and the standard deviation to test whether or not this is normally distributed. So of course, our first thing to do is to just look, right? And we sort of look at it, and we can see how this is maybe kind of normally distributed, because we do see sort of a general lump. It does have sort of a crazy long tail here. It does have this spike here. And so we might consider ways of one thing we could do is sort of say, okay, well, what are all the things that are in this price point here? And it looks like almost 200 rows, and they're Macintosh variety. So I could do now a text facet on that thing, and we see, no, there's sort of certain types of one. The grade might be the same. Let's see what the grade is on these. Okay, mostly US 1, whatever that means, that are sort of falling into this price range. And I can't remember what FR appear means. I think it's not that great. But anyhow, so we can maybe explore why that exists. And as we do that, we might find that there are reasons for excluding parts of the data that are not comparable, right? So when we talked about something like a normalized distribution, it's tempting to say that height is normally distributed, right? But it's not really just height. It's height by sex. Because if you look at height distributions, you'll actually see two lumps. You'll see two, we call it bimodal, right? You'll see two normally distributed data sets that are on top of each other and kind of overlapping because, of course, men in general are taller than women. But that doesn't mean that when they're sort of subdivided correctly, you don't get a normal distribution. And so it's not to say that we are always trying to subdivide towards a normal distribution, but it's to recognize that as we see things that may cause anomalies within that distribution, whether it's an outlier or something that's sort of causing this spike, right? And it might be totally genuine. It might just be that's the shape of the data set, but it might also give us a clue as to how things are differentiated within the data that we're looking at, right? There's some differentiating factor that is meaningful that we aren't aware of until we sort of see it expressed as part of the shape of this distribution. Anyhow, all of that said, what we want to look at here is we want to go back and look at our mean, which is about 27, and our standard deviation. So again, we did this bit in class, but just to say that if I go from 27 down to 17, and actually I think that might be exclusive. I need to check that. My apologies. So it's things that include 17 up to 27 and 37. Yeah, it's actually one thing I'm not, I need to double check is whether it's inclusive. But then we saw we had this 690 matching rows, and so if we look up our trusty calculator and do the math, we see that 690 divided by 915 is 75.4%. So it's not 68% exactly, right? Because again, we're looking at the mean and then one standard deviation around the mean. It's 75%, and then again, if we go down here, right, we have 15 matching rows, and so get out my calculator again. And so we do, 15 divided by 915, and how much is that? That's really only about 2%. So that's going to be a little different. So what we're comparing this to, again, is we want to be looking at that we want to be looking at this curve and what we expect to find within a certain, that's not what I wanted. I believe I have linked to this for you guys, so you don't have to do all this Googling. Right, so I should find about 13.6% between 1 and 2 standard deviations. So obviously that's not holding up on the lower end. But then let me see if I go, let's see, between 37 and 47. Yeah, I think I'm sort of shortchanging this a little bit, but I will get back to you all on which it's supposed to be. And then, so I have 75, right, which is only 8%. Taken all together, what did I have? 8% plus 2% plus 74.5%, 75.4%, right? So I have about 85.4%, which is not so bad, not great, but not terrible, right? So, again, this is always going to be a judgment call, whether you say I'm going to talk about this, I'm going to think of this as essentially normal or essentially not normal. But the point is that, again, it gives us, it still gives us sort of cutoffs and thresholds through which we can think about this. So again, going back to the sort of, silly question that we asked in class of, is $50 a carton a lot for apples? I think we could still say pretty confidently here, yes. And if we felt uncertain about that, we could go ahead and compare the median and the quartiles, in the sort of Q1, Q3 range and say, yeah, that probably still looks like a lot. So relatively expensive. And again, even just viewing this as a histogram gives us perspective on what the real outliers are. And through that, maybe we can start to create some hypotheses about what drives those outliers. why they are showing up the way they are. So again, if I look at these guys that are in my super high-end range, we see that it's Honeycrisp and Pink's Lady Crisp. Pink, it's weird. I think that's supposed to probably be, no, I guess it's a name. Anyhow, so what you guys are going to want to do, what we're going to ask you to do for Friday, I'm wondering if, no, there's a few Honeycrisps. Interesting. Where do they disappear? They don't. What we'd like you to do for Friday is essentially perform this analysis on your assigned fruit or vegetable. So you will download a week's worth of data, basically do just the quick calculations that we did, mean, median, standard deviation, interquartile range, top and bottom values, high-low values, and then bring it into OpenRefine, take a look at it, and basically just do the evaluation of what percentage of the values fall within one standard deviation, two standard deviations, and then your hypothesis for whether or not you think it's make an argument, make a 3-sentence argument for why you think it is a normal distribution or not a normal distribution, and that's it. So hopefully that shouldn't take you guys too long. We did it in class, and as you can see, obviously it's a pretty straightforward. Oh, you should calculate at least one normal score, again, just to sort of test that. That is all. So we'll post your assigned commodities, and you can get going with that for the weekend. All right. See you all soon.